So welcome back to our notes on transformations of functions, and in this video we're going to be looking at example 3, which is on the back page of the foldable notes booklet for those of you that are following along with those notes. Okay, in example 3 we're asked to write the equation given a verbal description of a function whose domain is a half-bounded interval, -infinity to -6 inclusive, and its range is another half-bounded interval from -6 inclusive to +infinity. The only parent graph that we have that has an restricted domain and range like that is the square root function, because it has an endpoint. And the square root function's equation is f of x is equal to the square root of x. And the parent graph of that square root function has its endpoint at 0, 0. It passes through 1, 1, and it makes a half of a sideways parabola. Right, that's the shape. Now, if this parent graph has been transformed so that its domain is -infinity to -6, right, that means that it can't be starting with its endpoint and heading off toward +infinity. Instead, it would have to be doing something like this, where it's been shifted 6 units to the left in order to be here at -6 with its endpoint and heading off in the -infinity direction. Now the range, though, is also a half-bounded interval, and that one, the y value is -6 where it starts and then heads up to +infinity. So this endpoint cannot be on the x-axis. Instead, it has to be moved down so that its y value has a lowest value here of -6. So with that domain and range information, I now know that this endpoint is at the coordinate -6, -6, and it's heading up and to the left, right, up because of the range going to +infinity, to the left because of the domain starting at -infinity and heading over to that -6. So now I read on, and it says this has no non-rigid transformations. So that means that there's no dilation. I don't have to worry about any stretch or shrink. So this guide point here is up 1 over 1 unit. So it would be located at -7, -5. Okay. So now when I go to put that information together into my equation, I know that my A is going to be a +1 because there's been no dilation and no reflection in the x-axis. I know that the B, because I have a reflection in the y-axis but no dilation, is -1. The H, that's my translation left or right. The H, because I got shifted over 6 units to the left, is going to be a -6. And then the K is my translation up and down. Since it got moved down 6, the K is going to be a -6 as well. So in the equation of this transformed function, I would have my function f of, and then the B is -1, then parentheses x minus a -6 will be a +6, and then I close the parentheses on my function, and then the K is plus -6 or -6. Now when I put that into equation form from my function form, that's going to be y equals, and then my f, my function, remember, is the square root of x, so I'll have a square root symbol. Underneath that square root, I have my b, which is a negative, and then parentheses, and then my quantity x plus 6, so that it shifts to the left 6. Out from under the radical then is my k, which is -6, and that would be the equation that would produce this verbal description. Now you want to be really careful. You'll notice I put a star here to highlight it, point that out. Be very careful mixing y-axis reflections with horizontal translations. And here I made these graphs for us ahead of time in Desmos so that you could see that the graphs are not the same. So here's the one that we needed to write, right? Negative quantity x plus 6 is under the square root. The minus 6 is outside for the shift down 6. And notice it's got that same shape that we had sketched out ahead of time. Now, if I didn't put those parentheses around that x plus 6, then I would have this red graph, and notice that's going to the right 6 units, not to the left. So leaving off those parentheses does not produce the same outcome. Those parentheses have to be there, right? Otherwise, you would have the equation, if you wanted it to make this blue graph, you'd distribute, have negative x minus 6, and then that wouldn't be in transformation form anymore, but it would still produce this blue graph. Okay, so you would be really careful mixing your y-axis reflections when you have horizontal translations. Okay, so if you would try this next problem on some scratch paper or a personal dry erase board and pause the video. Once you've figured out what the equation is from this verbal description, then you can restart the video and we'll go over the answer together. Okay, so welcome back. Hopefully you had a chance to try this problem on your own. We're asked to write the equation for a function with a domain that is all real numbers except 4 and a range of all real numbers excluding negative 2. The only parent graph that we have that has those union of half-bounded intervals for domain and range is the rational function's parent graph. And if you recall, the rational function is f of x is equal to 1 over x. And that produces a hyperbola that has a vertical asymptote along the y-axis, a horizontal asymptote along the x-axis, and then the hyperbola curves just like this along those asymptotes, passing through -1, -1, and +1, +1. Okay, so if we have we have a domain of all real numbers except for 4, that means we had to shift these asymptotes over 4 units. And if the range is all real numbers except -2, then it had to move down to 2 units from that y-axis. So my asymptotes now are going to be intersecting over here in the second quadrant, and that's going to be at the point 4, -2. Okay, that's where my asymptotes intersect. So when I write that equation, that A, because there's been no reflection or dilation, A is equal to 1. The B, no reflection or dilation, is also equal to 1. H, in order to have this asymptote move over here 4 units to the right, H had to be a +4. And then K, in order to get that horizontal asymptote down to K, had to be a -2. So when we put all those pieces of information together into the equation, we'll have f of x is equal to 1 over the quantity x minus 4 minus 2. And that produces this graph right here, where we have a vertical asymptote at x equals 4, horizontal asymptote at y equals -2, and then the anchor points for this graph are going to be here at 5, -1, and at 3, -3. Okay, so last but not least, here's the secret question for this lesson. You're going to write the equation from the verbal description below for a function with a range from -infinity to 2 inclusive. It has a vertex with an x coordinate of 3, it graphs a smooth curve that's been vertically stretched by a factor of 5. So go ahead and give that a try, and when you upload your notes to the Dropbox in Schoology, remember to upload your answer to this lesson's secret question as well.